In this video, we would like to discuss difficult questions in the textbook reading. And we emphasize the basic linear load and linked structure. The first question it is, read the following code, finish the program so that it finds and prints the smallest value in the linked list. In this question, it includes the two source code. One is interload, one is the customer linked list. Let's read interload first. So the interload, let's use the class diagram to represent. It includes the data value, and which is integer. And we also include next load PTR, and which is the same interload class as the data type. And except the constructors, this class includes the insert aft and also get next and print load. So the constructor, let's leave space for the constructor, and we have insert aft, right? I just briefly write in this way, get next, print load data. So this is just a print load data. We see all this data, let's define as the private data member. And the function here we use to retrieve or update the content. So this insert aft and use it to link the interload objects, make a linked list. And get next is to retrieve the next element reference. And the data value, there's no way to retrieve the data value. So it means here they have one specific method actually is missing. So we need to have a get value, right? Let's use get value to represent. And such that we need to insert one of the function method here. So we need to type public int get value. And then in this function body, we just simply return this data value. So then after that, it is after that we finish this class is interload class. This is something we need. Now we go to the customer linked list. In this one, they only have the one main function. In the main function, it created the head object, current object, last object. Let's use a different color to represent that. Let's write it down. So we have a head object, current object, right? And we also have a last object. And then let's take a look. The head object has been initialized with the -1 as the front, as the data value, and the last object, which is assigned over here, right? So in this statement, corresponding to is retrieval. Let's use a different color. So it get one data object. In this data object, it includes -1, and this is a long, right? So, and here the head object is a point here, right? Because head object is equal to this guy. And also last object also equal to this guy, right? Then they have a for loop. In this for loop, it randomly generates one and use the different color to represent it is a new inserted one, right? So it generates a different random value and also create the new interload, hold this random number. Let's just give arbitrary number, right? And then after that is insert this current this one. Insert this one after the head. Current object is assigned to be this new guy. And the last object for here, we'll insert this new guy to after that, right? So it means this one will be changed. So I erase that, erase this one, right? So this one will be changed and this one will be inserted here. And this is long so far. And also the last object needs to refer to this one, right? This one. So this reason, the last object has been assigned to be the current one, right? Current one. Let's use this one to represent. And then we erase this one, right? So, okay, so this is what we have the second one. So this loop will continue again and again, right? So when you insert more, so for example, line, let's say this is 17, right? So continually, it will follow this link and change this one to be here. Change this one to be here, right? And also, this will change the last, this one. Of course, this one will also be changed, right? And this one will go to here, right? And this one go to here, right? So it will continue and continue. This linked list will be increased. And in the note, then since they ask us to print the smallest value, so in this case, we need to write a specific function, right? We need to write a specific function because in this statement, in the main function, what it do it is it maintain, it create a linked list. And later, what they do it is they display this linked list, right? So corresponding to change the current object to be head object, and then print the load data. So it will print the negative one. And then retrieve get the next one and go to this looping. And go to this looping and print this one, get the next one, right? And here the current object is long. So this is print the whole linked list. Then the previous for loop is create this linked list, right? Good. Now we need to think about how can we write the code and such that we can find the smallest guy. So I'm going to move to the beginning of this main custom linked list body. And then I would like to insert a function. Let's say this is a public function, and this is static method. And since we want to return the smallest one, in this case, it's integer, and we find min, right? And then what do we give the input? What could be the input? So we say we need to give the linked list. Who is represented as this linked list? We see this head object, right? And head objects, the data type, it is an interload. So we give interload, and let's say this is the list head. Good, yeah. And then after that, so first let's say define some temporary variable, use to hold the data. And since the random general number is a positive number, so let's use -1 to represent the smallest guy, right? And also use this one to represent just the beginning. And then so the interload, and this we use, since we have to scan the whole list to find the smallest one, we want to use some temporary load. Let's define as a current load, current object, right? Let's just use a cur to represent the current load. And then we get list head. In this declaration, you can see we use this one, this is called a dummy node, right? We already use this dummy node, and in this dummy node, actually you need to just hold the link to the first real beginning of the linked list. And this data negative is kind of no sense data. It's just don't use that. This link to tell what is the beginning of the linked list, right? And then so use this one to retrieve the get next, because the data which come from this next reference of this head object. Good. And then after that, so we need to scan the remaining of the linked list and check each node by each node. So we can use a while loop. We say while URL not equal to long. Then what we do it is we say if res, if this is equal to -1 and res is assigned to be current get value, right? This is we already defined the value. This is tricky. And then, so we say if res greater than current get value. And then we can assign the res equal to cur get value. Then we assign cur sign to be get next, right? So it means we check this current vertex. If this vertex is smaller than the result, return the minimum value, then in that case we change the result, right? Or else we have to continue. We check next load. So this is a while loop. And then after this while loop finish corresponding to what we have the node URL, this should be current. CUR, current load is long, right? Then we quit. And when we quit from the while loop, we need to return res. Okay, then let's say after we finish this one, we have to link this function, put this function in the specific place of this main function. Since this is a print out all this loads the data. So now let's say we want to display system out print ln, right? We say the minimum value in the list is plus, and plus what we define the function and find the mean. And from the head object, right? So this is the head dummy load of the linked list. So now let's double check that and make sure what we wrote is okay. I think we miss one parenthesis, right? So now after we finish, we can click run. Let's see what happened. Okay, so it tells something's wrong, right? So this is static. Find the mean. Identify is required. Let's take a look. Let's see what is missing. You see what? Public, we one extra net is there, right? So now let's run it again. Still have something, maybe misstep. So cannot find the symbol. You see, they have another one, right? So this is a misstep. So double C, right? Should not have double C. Okay, let's see. So this is what we have the random generated list. So take a look at here. We see maybe 699 is the smallest guy. And so in this case, that is what we, let's clean the, what we draw. So this is 699, it's the smallest guy, right? So it means what we wrote, what we tapped, that is good. This is good design now, okay?